Hello everyone, welcome back again to another video from the AB3X Institute of Mathematics Education. My name is Akin, your math instructor, and in today's video we're going to be discussing method 2 of solving a pair of simultaneous equation. In fact, we're going to be specifically looking at the substitution method. Now, of course, there's this particular lesson is a 3-part series. This is in fact part 2 of part 3. Part 1 was posted. You can find the link pinned in the comments or in the description of the video. We had looked elaborately at the method of solving a simultaneous equation using the elimination method. Lots of examples are on that video, different types of examples, which variable to eliminate, which variable is the best variable to eliminate. So much more is available on that video, so you definitely want to check that one out before venturing off into this one. Alright, now I particularly provide math lessons for students that are at the secondary level, particularly for Caribbean students that are engaging in the math curriculum under the CSEC, CCSLC, SEA, EDXLs, and City and Guilds exams on a yearly basis. So definitely be sure that you are in fact subscribed to the channel and your bell notification is on for when I post daily and weekly lessons. Of course, do not forget to hit the like button if it is that you have found value from my content. Don't forget to share this out to your math communities, and of course leave some positive questions and comments down below. Please also be sure to check out all the other lessons that are available on the channel under algebra, trigonometry, coordinate geometry, so much more, and plenty more videos are coming out. All right, so definitely stay tuned, and we're going to improve our math skills video by video, lesson by lesson. So without further ado, let's dive on right in. So here we're looking at solving a pair of simultaneous equation, method 2, which is specifically known as the substitution method. We're going to be discussing when is this method best used, how to identify that this method is the method to use, and why is it more effective than the elimination method. But let us just look at some identification catalysts when it comes to identifying this particular method. Now, this method is useful when one of the 3 scenarios presents itself. Now, number 1, for me personally, when I look at a pair of simultaneous equation, I'm always looking for if when one of my variable, one of the x or the y or the a or the b, if one of my variable has a coefficient of 1, then I know that this method can be used. And particularly, I find that this method is a little bit more simpler than the elimination method. I mean, that then boils down to personal preference then. Number 2, it is of course whenever when you have a linear equation that is combined with a quadratic equation. That is going to be a particular video that we're going to be discussing in part 3. So ensure that you are subscribed to the channel for when that video is posted. And for number 3 here, we're looking at when the variables are connected or joined together by a product. Now, number 2 and number 3 are particularly catalysts that we use to identify what is known as a simultaneous quadratic equation, or what some textbooks will refer to as linear and non-linear equation. So we are going to be using number 1 here as our identification catalyst in using this particular method. All right. Now, of course, remember that the prerequisite skills for solving these types of equations is that you must have a somewhat of a rock solid foundation in solving a very basic linear equation, such as transposing to the left or to the right, splitting the product, multiplying both sides of the equation by the denominator. Those little things you definitely want to have a good understanding of. Of course, I have a solving linear equations playlist pinned in the comments, so definitely check that out as well. All right, now let us dive on then into what is exactly the objective of the substitution method. Now, the objective of the substitution method here is to pretty much make one of the variables the subject of the equation. So whichever equation contains the variable with a coefficient of 1, that particular variable is our target. That is the variable that we want to make the subject of the formula. Do check out changing the subject of the formula video that is pinned also in the description of this video. Now, once we have made that variable the subject of the equation, we are then going to be substituting the expression that is related to that variable into the other equation that is connected. All right, and then of course what's going to happen then is that we're going to end up creating one single equation containing one variable, which makes it quite easy for us then to solve the equation. Now, once we have finally obtained the value of our first unknown, just like in part 1, after finding the first unknown, we're then going to substitute the first value of the first unknown into what I would refer to as the third equation. All of this will make sense in just a few minutes from now. All right, and here's a hint. This method is best to use, as I said earlier, when one of the variables in the equation has a coefficient of 1. Now, please note that this method can still be used even if the coefficient is not 1. It just basically causes a bit more challenge. So not every student are able to handle working with fractional equations. So I do recommend then that apply this method only when your variable has a coefficient of 1. So let's dive on right in here with our very first example. Now bear in mind that for exam purposes, the examiner is not going to specify what method to use. You must be able to recognize if it's a linear equation or if it's a linear non-linear equation. And throughout my videos, you're going to be able to recognize when you're dealing with either of the listed equations above. All right, now what we're looking at here is in fact the first equation here, x plus y equal 7. And of course, 2x minus y equal 5. Now, this particular equation can easily be solved in a couple of lines using the elimination method. However, of course, what we're trying to do here is that we're trying to get, say here, the equation then to be used by the substitution method. So here I'm going to definitely go ahead and call, say here, this equation 1. And we're going to call, say here, this equation 2. All right, and then from here, equation 1 and equation 2, I'm going to pay close attention to which equation has a coefficient of 1. Now, it so happens that this equation number 1, both of its variables has a coefficient of 1. Here's a 1 in front of this x and there's a 1 in front of this y. So in this case here, I have an option. Do I want to make x the subject of my equation, or do I want to make y the subject of my equation? So it really depends on you. So for me here, I'm going to write a statement and I'm going to say from equation 1, I'm going to make x the subject of my equation. So if I'm going to make x the subject of the equation, my objective here is to simply move across, say here, the y to the other side of the equation. So I'm going to subtract y from both sides. So from equation 1 then, x is equal to, say here, 7 minus y. Therefore, I'm going to call that then equation 3. That's going to be a crucial equation later when we're trying to find the value of x. So now what's going to happen here is that I'm going to go ahead then and I'm going to say substitute this equation here, this expression here, 7 minus y for x. So I'm going to go ahead and I'm going to sub 7 minus y as an expression for x in, of course, equation 2, because it is equation 1 that created equation 3. So I'm therefore going to substitute my new expression into equation 2. So anywhere I see an x, I'm going to replace the x in equation 2 with 7 minus y. So this becomes 2 multiplied by 7 minus y, because that's 2x and x is 7 minus y. So 2 multiplied by 7 minus y minus y, and that's equal then to 5. And now what you have here is a very straightforward equation with one variable, one unknown. So now easily then I can go ahead then and I can distribute the 2 here and distribute the 2 here. So then I end up with 2 times 7, 14, 2 times negative y, negative 2y, minus y equal 5. Now I can fix this equation up a little bit here by saying, say here, negative 2y minus y, and then of course I'm going to have 5 on the right side. I'm going to simply transpose the 14 to that side. So I'm going to have negative 14 here. So that's 5 take away 14. So I've just transposed like terms. So bringing this up here, I'm going to end up with minus 2y minus 1y gives minus 3y. And so what we have then is 5 take away 14 is negative 9. So then I can split the product here by dividing both sides by minus 3. So then y is equal to minus 9 divided by minus 3. Y is equal to positive 3. And so therefore that is the solution for y. But of course we're not finished. So therefore we're then going to re-substitute the value of y here, which is now 3, in equation 3. I could put it in equation 1 or 2 and get the answer, but equation 3, I already have x as my subject. So I can therefore just go ahead then and say here that x then is equal to 7 minus y, that is 7 minus the value of y, which is 3. Aha, x is equal to 4. And that is it. That is it. That is how you solve this equation using the substitution method. Now, do you find it easier than the elimination method? Let me know in the comments down below. Bear in mind that the elimination method has limitations because it can only be used to solve a linear equation, 2 linear equations. It cannot be used to solve a quadratic linear equation. All right, so it's good to know both methods. Let's exercise our new skills that we have earned here in another example. Now, in our first example, you recognize here that we had a choice between making x the subject and making y the subject. And so here, we don't really have a choice. It is evident then that the only variable here with a coefficient of 1 is in fact the x. So that now becomes our target. That's the variable that we want to make the subject of the equation. So once again, I'm going to write a statement. I'm going to say here from equation 2, remember this is equation 1 and this is equation 2. So from equation 2, I'm then going to isolate x simply by moving the negative 3y to the other side, or as you'd say here, add 3y to both sides. So x then is equal to 1. Negative 3y has been transposed across the equal sign. It becomes positive 3y. So then now this then becomes equation 3, which I'm then going to be using later on in the problem, in the resolution of this problem here. Then I'm going to then substitute the value of y in here to get x. Now I'm therefore then going to substitute now. I'm going to sub 1 plus 3y for x. And of course I'm going to be using equation 1 because it is equation 2 that was used to create equation 3. So the substitution has to be made in equation 1. So here 4x in equation 1. So let's go ahead and do just that. We're going to say then 2 open bracket 1 plus 3y. Remember that when you're dealing with a binomial expression such as 1 plus 3y, or you're dealing with something like, say here, 7 minus y, you have to put them in a bracket because the number on the outside will be distributed with the terms on the inside, or both of the terms. So 2 open bracket 1 plus 3y minus 5y equals 3. Now distributing here and distributing here, 2 times 1 is 2, and 3 times 2 times 3y is 6y minus 5y equals 3. And so easily then we can group here like terms. We can say 6y minus 5y, and then I'm going to be transposing the 2 to the right side, so I'm going to end up equal to 3 take away 2. Positive 2 goes over, becomes negative 2, and the 6y and the 5y remains on the left hand side. So then what do I have then? 6y minus 5y is, of course, y, and say here 3 take away 2 is 1. So therefore y is equal to 1. Now easily then I'm going to sub, say here, 1 for y in always equation 3. I've already created equation 3 by making x the subject, so therefore x then is going to be equal to 1 plus 3 times the value of y, which in this case is 1. Therefore x is equal to 1 plus 3, which is therefore equal to 4. So x is 4 and y is 1. Again, let me know if you find that this method is a lot more easier than the elimination method. Let me know in the comments. Now, I only have 2 more examples here for you, and so I'm just mixing up the problems a little bit here. Alright, and here's a tricky little example. Why I use this example here is that, again, we don't really have much of a choice when it comes to which variable here to use as the subject of our equation. Here, the only equation, in fact, the variable here, none of the variables here has a coefficient of 1, but we have a variable that has a coefficient of -1. And so if you end up with this sort of situation here, I do recommend that also you keep your focus on this variable here, -x. So with this particular equation then, I can therefore say from equation 2, so from equation 2, because this is equation 1 and this is equation 2. So from equation 2, I'm going to say here x is equal to, now the problem is when a student transposes the 3y like what we've been doing, they leave the subject negative. So in this case here, I'm not going to transpose what's connected to my subject. I'm going to transpose this subject because I want the subject to be positive. All right, so instead here, instead of bringing over the 3y like I would normally do, I'm going to go ahead then and bring over, say here, the x, and then bring back over, say here, the 7 on here. Okay, so from equation 2 then, I'm going to have 3y left on the left hand side, -7 comes over, becomes +7, and therefore then that is equal to +x. So this time I have my subject on the right side. Now if you want, you could turn it around and say x is equal to 3y plus 7, same difference. All right, so once again I'm going to substitute, I'm going to substitute 3y plus 7 for x in equation, say here, 1. All right, so let's do just that. We're going to go ahead then and say in equation 1 then, wherever I see an x or x's, I'm going to replace that for 3y plus 7. So that's going to be 3 open bracket 3y plus 7 minus 2y, and that's equal to 7. Now go ahead and distribute 3 here and 3 here. So we have 3 times 3y is 9y, and 3 times 7 is 21. Take away 2y, and that's equal to, say here, 7. All right, so once we've done that, then we can simply group like terms. So I have 9y minus 2y, and that's going to be equal to 7. I'm going to subtract 21 from both sides, or transpose 21, it becomes negative 21. So 9y minus 2y, let's just bring this up here. 9y minus 2y is 7y, and 7 take away 21 is in fact negative 14. So if I split the product by dividing both sides by 7, I'll end up with y is equal to negative 14 divided by 7. It so happens that y is equal to negative 2. Now I can therefore then quickly go ahead then and say here negative 2 for y in, say here, equation 3. Always equation 3. So then here we have 3 open bracket, say here negative 2 plus 7, and that will then give me the value of x. And so easily then I wrap this up then and say 3 times negative 2, that is negative 6, plus 7, that is equal to x. So it so happens that 1 is equal to x. That's my final result. Say here y is negative 2 and x is equal to 1. Alright, so you can see that the substitution method, although highly underrated, not taught a lot in the secondary schools, it is quite an easy process to solve a pair of simultaneous equation. Again, as I said, this method is best used when your variable has a coefficient of 1. Now for our last example here, guys, you've seen here where at all times, all my examples here, we've always been making x the subject. So here is just another one here where we have now the y being the variable with the coefficient of 1. So I'm going to then go ahead then and say here that from equation 1, y, that's the focus right here, y is equal to 9, and I'm going to transpose the negative 2x to the right side. I'm going to end up with positive 2x. Now I've just created, say here, equation 3. Bear in mind that this is equation 1 and this is equation 2. Alright, so equation 3 you can see is quite useful when we come to the end of the question. So then I'm going to substitute 9 plus 2x for y in equation 2, because I used equation 1 to create equation 3. So therefore the substitution has to be made in the other equation, which is in this case here equation 2. So then I'm going to have 3x. Remember, I'm not substituting for x now, I'm substituting for y. So 3x plus 4 open bracket 9 plus 2x, and then that is equal then to 14. So now we have an equation all in x. 3x plus 4 times 9 is 36 plus 2x, and that's then equal to 14. Let's group like terms here. So we have 3x plus 2x is equal to 14, and I'm going to subtract 36 from both sides, or transpose 36. It's going to become negative, say here, 36. All right, and so therefore then 3 plus 2 is therefore equal to, say here, 5x, and 14 take away 36 here, that's going to be, say here, oh, did I make a mistake? I think I did. 4 times 9 is 36. 4 times 2 is in fact 8. Alright, so 4 times 2x is in fact 8x here. So therefore then 3x plus, say here, 8x. Quickly catch myself there, guys. So 3x plus 8x, that's going to be equal to, say here, instead of being 5x, it's going to be 11x. And 14, say here, take away 36 is going to give us 22, negative 22 at that. And so if we split the product here and divide both sides by 11, then x then is equal to negative 22 divided by 11. So happens then that x is equal here to negative 2. So therefore our final result for this question here is that y, oh, we're not done. In fact, we only got the value of, say here, x is negative 2. So we can go back here then and say y is equal to 9 multiplied by, 9 plus 2 multiplied by negative 2. And then of course 9, 2 times negative 2 is negative 4. So we end up with y being equal to 9 take away 4. Y is therefore then equal to 5. Alright, and that is it. Y is equal to 5 and x is equal to negative 2. Alright, so that is pretty much it. A couple of mistakes were made here, caught myself. We're back in line, and that pretty much gives you a rock solid idea of how to apply the substitution method. Now of course we're going to be diving off into method number 3 in part 3 of our simultaneous equation series. And so that's going to be a very interesting video. That particular question gives many students many challenges. So I'm going to have at least 3, maybe 4 or 5 examples that you might encounter when it comes to solving a pair of simultaneous quadratic equations. So definitely stay tuned for that and you should be okay. All right, so thank you so much guys for watching. If you find some value and you were able to learn something from this video, do not forget to leave a like before you go. Leave your thoughts and comments down into the comment section below. You can find information in regards to my online and private tutoring classes in the description box below. The phone numbers are down there, and of course feel free to leave your donations to my PayPal that is pinned. The link is pinned in the comment section also down below. All right, so all the best on your exams coming up. Many more tutorials are coming, so stay tuned. Do not forget to subscribe, leave a like, and I'll see you next time in another tutorial. Until then, take care. Bye bye.